It's her. Hi, Emitle.
Hi, ma'am.
Hi. How are you doing today?
I'm good here.
That's good. I hope you had a good birthday. Do you have a question?
No, ma'am. I wanted to answer.
Okay, cool. What are you answering? I did ask for the part in yellow, but anyone will do.
Um, the the part in purple, ma'am.
Okay, yes.
The part in purple is the basement.
No, not our base.
It's
So
the
the part in
coefficient.
purple is all of it. So it refers to the 3 and the x and the and the 4. I was almost going to say what part it's called. The 3 and the x and the 4. So all of it, when we combine it together, what do we call that? It's not an equation. Do you want to try again? Or do you just not know?
It is the coefficient.
You're naming parts, but not the purple part. The purple part is all of them. Let's see if Itandile can help you. Itandile, do you know the answer for the purple one? Itandile, you can unmute and answer.
Ma'am, I'm very confused. Which part should I say?
The purple part. So my...
But then, ma'am, the purple part is the power. And then...
Exactly. The purple part is our power. Yes, you were saying, and then? Itandile, is that all?
Yes, ma'am, that's all.
Okay, cool. So in terms of the other parts, I saw somebody did answer my yellow little bit. Somebody did answer my yellow little bit and said the exponent. That was Tando. Thank you, Tando. You are 100% correct. The 4 in this part is called my exponent. It is not an expression. Bree did get the power correct. Itandile, you've written, is green the whole number? It is a whole number, but in this case, my whole number is called the coefficient. My whole number here is 3, which is called my coefficient. And lastly, we have x over here, and x deals with this part over here. And Itandile has raised her hand again, I think. Yes, Itandile. Blue is the base. Thank you. I see
Ma'am,
you
and then the
answering.
blue part is called the base, ma'am.
100% correct. So if anybody missed last week's lesson, here's a recap on how we know which part we are talking about when we are dealing with exponents. So let me just lower the sound super quick. Yes. So we have the coefficient. Now, for those of us who are still a bit confused on the coefficient is the number that is in front of my base. Because have a look at it. X was my base. How did I know X was my base? Because my 4 was attached to the X. So the base, and so let's write that. Let's write this over here. My base is what my exponent is attached to. Okay, so if you are confused about what is the base and what is the coefficient, have a look at your exponent, because everybody knows what the exponent is. It's the little number at the top. And so you ask yourself, what is my exponent attached to? Okay, and from there you'll get what your base is. And then to get what our coefficient is the number in front of Itandile says she can't hear. Can everybody else hear me, should I say? Please just give me a yes or no or a thumbs up if you can hear me. Yes. Kungawa says yes. Mihle says yes. Okay, Itadile, if you can't hear me, try checking that you are still connected to audio and that your volume is up. If not, try leaving it and joining again. Okay, cool. So our coefficient is the number in front of my base. And thank you to everybody answering in the chat that they can hear me. So that's how we know the difference. My base is what my exponent is attached to, and my coefficient is the number that's going to be in front of the base. And so those are two different things. My base is different to my coefficient. They are two separate things that we deal with. When we combine our coefficient, our base, and our exponent together, the whole thing is called a power. Now, for those of us who were in last week's lesson, we did law 1. Law 1, I'll give you guys a hint. Law 1 was the law of multiplication, and law 2 was the law of division. Can somebody tell me, what did the law of multiplication say? What was law 1? Immediately. Yes, immediately.
So ma'am, the rule for law 1
Mhm.
is when multiplying powers with the same base, keep the base the same and add the exponents together.
100%. Thank you for that beautiful answer. And it was almost word for word. When we multiply powers with the same base, what do? We go ahead with the same base. What do? I keep my base the same and I add my exponents. So let's just remember this first little bit of the law tells me when can I apply law 1. The second little bit tells me how to apply law 1. And then the law of division, can somebody tell me what that was? Feel free to type it in the chat as well if you know the answer. Is it and equal positive? Okay, so Mohammed, we are dealing with exponent laws over here. So yes, a negative and a negative does equal a positive. But that just has to do with multiplication in general, not multiplication of our exponents as such. So when you divide powers with the same base, minus the exponents, 100%. So when we are dividing, that's not how you spell dividing. When we are dividing powers with the same base, and so again, what was my criteria of when I can use it? I need to have division and I need to have the same base. Same. I can't spell all right today. I need to have the same base, and with multiplication, I need to be doing multiplication and I need to have the same base. So when we are dividing powers with the same base, what do? I keep my base and I subtract exponents. This one was a little trickier. If you were here last week, you'd see that you do your subtraction where the exponent is the biggest. And Bree, you asked, subtract the exponents. 100% that is what we do. We subtract the exponents. And let's do a little bit of a recap. So this has been on the board for some time. Has anybody tried it? Does anybody want to share an answer or help me out? I will get started on it so long. Let's do this. Okay, so let's have a look at this. We can use the method SNV to make our life easier. Let's deal with our signs. I can see I have a negative divided by a positive. And I know that's going to give me a negative. So immediately I know, okay, my answer is going to be a negative fraction, whatever it is. What is my n? My numbers is 3 divided by 6. And what is 3 divided by 6? If I were to simplify that, I would get a half. What is my variables? I have two variables over here. I have my x variable and I have my y variable. Over here, I can see I have x squared divided by x cubed. And then I have y to the power of 1 divided by y squared. And so, Liaho, I see you've put an answer in the chat. Let's, work this out and see what we get. Okay. And then we have our y's over there. Now, let's look at this. I don't want to say 2 minus 3. So what am I going to do? Instead of saying 2 minus 3, when I do my working out, I'm going to say x and I'm going to go 3 minus 2. But what does that mean? It means I do my subtraction at the bottom. And let's look at the y's as well. I don't want to say y1 minus 2 because I don't want a negative number. So I'm going to do my subtraction at the bottom here as well. And that is going to be y to the power of 2 minus 1. And so let's look at what that would look like. I know my fraction over here is going to be a half. I don't have my x anymore and I don't have my y anymore. What I do have is I have x 3 minus 2, and I have y 2 minus 1. That is going to give me negative 1 over 2x and y. So, Liahu, you were close. You missed out your y. Why did you miss out the y? 3 minus 2 is 1, so we still have x to the power of 1. And 2 minus 1 is 1 as well, so that will also be y to the power of 1. The other way we could have done that, just again quickly, is we could have said, okay, let's look at it. I could have said, Tando, you've got the answer correct over there. I could have said 3 goes into itself once and 3 goes into 6 twice. So I'm simplifying my fraction. I then could have said y goes into itself once and y goes into y squared twice. So that means I can cancel out one y here and I can cancel out a y there. Then over here, I can cancel out my 2 x's over there, and that is going to leave me with an x at the bottom. And let's see, what do I have? I still have a negative. I have my 1 at the top. I've canceled out my 3 and I made it a 1. And that's multiplied by 1 multiplied by 1. And what do I have at the bottom? I have 2xy, which just gives me negative 1 over 2xy. Okay, I hope that made sense. So there are two methods to doing that. You can either use the cancellation method or you can use the exponent law method. With the cancellation method, you kind of go ahead and you look at it and you say, let me erase. You go ahead and you look at it and you say, okay, I have 2 x's on the top. I have 3 x's at the bottom. If I take away 2 x's from the top, it means I'm going to take away 2 x's from the bottom as well. And I know x cubed is x times x times x. And so if I take away 2 x's there, what am I left with? I'm left with the 1x. And here I took away 1y from the top, and at the bottom, I had y squared, which is y times y. And if I take 1y away as well, because remember what I do at the top, I must do at the bottom, I'm left with my y at the bottom as well. Valentine, you said you're kind of lost. Where did we lose you? What is it that you're not understanding? Okay, yeah, so this is that for this one revision question. You guys can take a screenshot or ask questions now. Valentine, I'm going to move on. But you are still able to ask or tell me where you've been lost or raise your hand to ask a question. But for now, I'm going to move on. So we have our next one over here. it is 2a times 3a squared. You guys can raise your hand to help or answer in the chat. If we do it S in V, it would be a positive times a positive. I then have my numbers, which is 2 times 3. My variables is a to the power of 1 times a to the power of 2. And what do I know? When I'm multiplying powers, they have the same base. I can keep my base, add my exponents. And so let's write our answer. This one wasn't bad at all. 2 times 3 is 6. So my answer is going to be 6a 1 plus 2. And Thando, you have the answer beautifully. That is going to be 6a cubed. So not bad over there. Let's move on to our next little one. Again, looks difficult. Not really though. Let's do S in V. So let's go S in V. My signs, that's a positive, positive, and a positive. So it's going to be a positive times a positive, which is a positive, and then times another positive again. My answer I know now is going to be a positive answer. Ma'am, the Zoom keeps kicking me out. I'm not sure why it's doing that. I know sometimes when my internet connection is like a little bit shaky, it just kicks me out as well. So maybe try checking your connection and seeing that if that helps. Or obviously if you see your connection is a bit spotty, then that would be the explanation for that. Okay. So we've dealt with our signs. Let's look at our numbers now. 4 times 6 times 2. And in case you've forgotten, when we talk about our numbers, those are my coefficients. Because usually what happens is my coefficients are the one that we actually have numbers for, and the rest of it is just variables. So I can multiply the numbers that I know. 4 times 6 times 2. Can someone give me the answer for that? 48. Lufuna, you were so fast. Good job. 48. Let's look at our variables. How am I going to deal with my variables? So I have my x variables and I have my y variables. I can see it's all multiplication. So it's x to the power of 13 multiplied by x to the power of 8 multiplied by x to the power of 3. And then if I group my y's together, I can group these two together, and that is y to the power of 12 times y to the power of 13. And let's now do my answer. My answer is going to be a positive 48x. And now I know I'm doing multiplication of powers with the same base. So what am I doing here? I'm going to keep my base and I'm adding up my exponents. 13 plus 8 plus 3. And then I also have my y variable, which will be 12 plus 13. And then we end up with 48x. 13 plus 3 is 16. 16 plus 8 is 24. That sounds right in my mind. If I've made a mistake, somebody let me know. And then 42. Okay, so that is my answer for this one. Valentine, I hope that as we're going through these, things are starting to make more sense and things are adding up. Does anybody have any questions on this? And now is the time to screenshot as well for those who want to. 24 and 42. Thank you, Tando, for confirming my answer. Okay, great. Let's move on to, I think, what is our last revision question. We have some division over here. Anybody want to help me? That's good, Valentine. I'm glad to hear that. If there's anybody who wants to help me, Tando, you always have the answers in the chat. Why don't you try answering one with us? I will get started on it. We have S in.
Ma'am, I'm still calculating.
That's okay. Do you want me to wait for you?
Yes, ma'am.
Okay, I will do that. So I think we can all take this minute to do our calculations and see if we're gonna get the same answer. It always helps the most when you do it on your own and then you check your answer. Because when I do it, it's easy to say, oh, like, oh, I knew that, like I could have done that. But when it's actually time to do it yourself, people tend to get lost. So take this minute to try and figure it out yourself, and then we'll mark it when Tando is ready for us. Tando, you getting there?
Ma'am, I'm done, but I'm not sure of my answer.
That's okay. You don't have to be. Tell me what you've done. Let's see.
So, ma'am, I took X and I took the X 15, then I said X 19 minus 15 because the bottom number is bigger than the top one.
Okay,
And then,
so I do it at the bottom, right?
yes, ma'am.
Uh-huh.
And then the Y stays at the top, and then I said 22 minus 17.
Uh-huh.
And then next to the Y, I think there's supposed to be a 1.
Yes, there is supposed to be a 1 because I've moved my X down. Yes.
Yes, ma'am. So my answer was Y to the power of 5 over X to the power of 4.
And that is 100% correct. And so you did that beautifully, Tando. And what I want to tell you is I could have written this 1 over there, but as we know, anything times 1 is just going to be itself. So we don't always have to write in that times 1.
Yes,
So
ma'am.
cool. Thank you so much, Tando, for that. For those of us who did try it and attempted it, check your answers. Let me know if you got it correct, if things are making sense. And just for an explanation, how did Tando get this? We said, okay, I have X's and I have Y's, and I can see I'm doing division. So Tando said, I'm going to use law 2, which says when I have the same bases and I'm doing division, I keep my base and then I subtract my exponents. And so what Tando did is Tando said, okay, I have X and I have X over here, but I don't want to say 15 minus 19. So what she did is she took the 15 down to the bottom to do my subtraction. And that's why my X stayed at the bottom and it was 19 minus 15. And then we had our Y values. So that was Y and Y. And here, my numerator, the exponent in my numerator here was big enough for me to do the subtraction at the top. And so that's why Tando kept it at the top and went 22 minus 17. And when we just do our subtraction, this is what we are left with. So I hope that makes sense. I hope you've screenshotted if you needed to. I hope you've corrected if you needed to. I'm going to move on to what we came here for today. We are now doing our next exponent law, which is distribution. And so how this works is it's exactly what it says here. It says when you raise a power to a power, and I'll explain exactly what that is in a second. But when we raise a power to a power, what do? We have to multiply our exponents. And so now let's think about raising a power to a power. What do I know? I know a power is something like that. That is a power. When I say I raise it to a power, I'm saying I'm taking this power and I'm making the exponent bigger. I'm raising it to another power. So when I have something just like x, I say I'm going to raise it to a power if I add an exponent. So here, I'm going to raise a power to a power if I add another exponent. So I hope that raising a power to a power makes sense. All that it is that we take a power and add another exponent to it. And so let's look at what we do here. If I had to look at, we have a, which is my base, to the power of m, and this is being raised to the power of n. Okay, and so what do we do here? My rule is that I have to multiply my exponents. And so this, in case you didn't know, a mn is the same thing as a m times n. So that is that on that. And so if we had to do a super quick example, if I had 3 squared and I raise that to the power of 3, my rule over here would be that I take 3 and I multiply my exponents, and that would give me 3 to the power of 6. And then we could use our calculator to get the value of what that is. So what I want us to see here is what is the difference between this rule and my multiplication rule. And when I talk about my multiplication rule, I'm talking about rule 1. What is the difference? What I want you to see here is that when I have law 1 looks like this. Okay? Can you see that in law 1, there are 2 bases and 2 exponents? When we apply law 3, there's only 1 base, but there is still 2 exponents. Okay, I hope that made sense to all of us. If you have any questions, please feel free to raise your hand, pop it in the chat, whatever makes you feel most comfortable. We're going to start now with some examples. So I have 2 up on the board. We're going to start with the first one. Feel free to work out the next one if you're done. Let us look at it. So what I have here is I have 2 to the power of 3. That is a power. And I'm raising this whole power, and that's why it's in brackets. I'm raising this whole power to another exponent, to another power. And so my rule here is I know I'm going to apply law 3. And what does that look like? It tells me to just multiply my exponents, and that is going to give me an answer of 2 to the power of 6. If we have to look at B, how would we do B? Let's keep in mind I have a -3, but it's outside my brackets. So all I know that I'm going to do is I'm going to bring down my -3 and then apply law 2 to whatever is, not law 2, and apply law 3 to whatever is inside my bracket. And what is inside my bracket? It's my power. And so I'm going to go 2 times 3. And this also gives us an exponent of 6, and it's going to be -3x to the power of 6. And so by doing this -3x, what you guys should know is it really means -3 times x to the power of 6. Cool. I don't see any questions in the chat. Can everybody give me a thumbs up that we have followed what we've done here so far? Nkuli, I see your question. I just wanna get the thumbs ups, and then I'll read your question and answer it. But can we please give me some thumbs ups to tell me that we are with me? Morangi, thank you so much for your thumbs up. Pando. Okay. Valentine, I see a thumbs up. I love to see that. Okay, so we're all following. So I think that's it's not a really difficult rule. Where it does get difficult. Oh, and let's answer Nkuli's question super quickly. What happened if they gave you q squared times p cubed? Okay, so if I had something like q squared times p cubed, I can see I'm dealing with exponents. I'm going to look at my exponent laws. What do my exponent laws say? I have law 1, which tells me if I have the same bases and I'm doing multiplication, I can use law 1. What I'm seeing here is I do have multiplication, but I don't have the same basis. What does that tell me? I can't apply law 1. Let's try law 2. Law 2 tells me if I'm doing division and I have the same basis, I can apply law 2. So I can't apply law 2 here because I don't have the same basis, and I'm doing multiplication instead of division. So law 2 can't work over here. Law 3 tells me I can use it when I'm raising a power to a power. This is not raising a power to a power. It's multiplying a power by a power. And so law 3 doesn't work. And so far, the laws that we know cannot be applied. And so this is as far as I can go with that. I hope that answers your question, Kuli. When we can't apply any of our laws, then that's as far as we can go. We can't simplify any more than that. Okay, and I still see some thumbs ups were coming in. Thank you guys for that. Let's look at C. Okay, C. This is where it gets a little bit tricky. What I want you guys to see is that what if we had something like -2 squared? Can somebody tell me what the answer would be to -2 in brackets all squared? It would be 4. Why would it be 4? Thank you, Tando, for that. Not undefined, but it would be 4. Why? Because -2 all squared means -2 times -2. And what do I know? That gives me a negative times a negative, which is a positive, and 2 times 2 is 4. And so what do I know about something like -2 x to the power of 4? It really means -2 times x to the power of 4. And so when we have an exponent outside of my brackets and all of this is inside my brackets, what I have to do is I have to apply that exponent law to both of my numbers inside my bracket. And so what would that look like? That would look like me saying, okay, -2 has an exponent of 1. So my answer is going to be -2 to the power of 1 times 2 multiplied by, and I can actually leave out my brackets, times x to the power of 4 times 2. I hope everybody understands how that happened and where I came from with that. I applied law 3 to my -2, and I applied law 3 to my x to the power of 4. And so what am I going to be left with? -1, -1, -2, and that is going to be squared, is going to give me this, which is going to be 4 times x, and 4 times 2 is 8, which we can just write as 4x to the power of 8. Are we happy with this one? This one was a little bit more difficult, but does this make sense, guys? Again, I'm going to need some thumbs ups because I just want to make sure nobody has been left behind. Yeah, well, thank you. Hello. Okay, I'm seeing some thumbs ups. It's not as many as before. Nkuli, where did I lose you? Shady got it. I'm glad to hear it. Nkuli, raise your hand. Let's talk about it. Let's talk about what's confusing you. Yes. Let me unmute super quick. There we go. I've asked you to unmute. Tell me where did you just, get lost? Where were you like, this isn't making sense?
Ma'am, I got lost where you went into when you went out the brackets. I got lost there because where did they go?
So all that I did is, because I did my distribution in, so are you following me that this was almost the first step that I did over here, where I've written a number 1 next to it?
Yes.
Okay, so because I distributed my exponent into my brackets, once I've done my distribution, I can remove my brackets. It's kind of like when we have something like 2 and then x plus 4. How do you do this? You distribute. You say 2 times x is 2x and 2 times 4 is 8. And then we don't need our brackets anymore, right?
No, not anymore.
No. And so I could have kept my brackets, but all that would have happened is it would have just gone down with me right until the end, and then I would have removed the brackets at the end, and it would have just been 4x to the power of 8. You with me there?
Oh, yes.
Okay, so once we do our distribution, there's no need for our brackets anymore because we don't need to separate anything anymore. You with me there?
Yes.
Okay. Are you up to speed now, or is there somewhere else where you got lost?
No, I'm up to speed.
Okay, great. Immediately, I think you have a question as well. Thank you, Nkuli, for your question. Immediately, let's hear what you have to ask.
Ma'am,
Mm-hmm.
so you see in the brackets, ma'am, the first set of brackets, which is
Yes.
negative 2
Mm-hmm.
to the power of 1 times 2. Can you please
Mm-hmm.
explain how you...
How did I get that? Okay. So remember what I said? I said that the law says that when I have a power being raised to a power, I use law 3. And what does the law say? The law says that I multiply the exponents. Can you tell me immediately what is the exponent of negative 2?
Is 2, ma'am.
No. What is the exponent, the invisible exponent of any number?
It's 1, ma'am.
It's 1. So my invisible exponent here on top of my 2 is actually 1. And so that's why I separated it over here. And maybe I should write it in here, that here my invisible exponent is 1. So I'm applying law 3 first over here. And then I go ahead and let me erase this. Let me actually redo this to make it more understandable. So what I did is I said that, okay, negative 2 multiplied by x to the power of 4. And that is squared. But I know that 2 has this invisible exponent of 1. You with me there?
Yes, ma'am.
What I then did is I said, okay, I'm going to apply law 3. So I'm taking law 3 and I'm applying it to my exponent and 2, and I'm going to apply it to my x. You with me there?
Yes, ma'am.
And so because I've applied law 3 over here, what does my law say? It says I need to multiply my exponents. And that is how I got 1 times 2 over there.
Thank you very much, ma'am.
Pleasure. Does that make sense now?
Yes, ma'am.
Okay, cool. Thank you for your questions, guys. I think it's really good to ask questions because I'm sure there's other people that are also very lost but don't even know what question to ask. So I hope that anybody who was lost understands now, and you feel we will 100% do questions. Let's try this one over here. I want you guys to see something. Why is this different? My negative 4 is outside my bracket. So because it's outside my bracket, I can't go take my exponent and apply it to something outside my bracket. That's not how law 3 works. So what I'm going to do is I'm going to say, okay, I'm going to bring down my negative 4, and that is going to be multiplied by negative b, and then let's apply law 3. 3 times 2. I hope everybody understands where I got that from. And then it is going to be negative 4 times negative b to the power of 6. And then we now have a negative times a negative. That's going to give me a positive 4b to the power of 6. Does that make sense, everybody? Or rather, if it doesn't make sense, please ask me a question. I think it should be pretty okay. It's a lot better than the one where we have our number inside the bracket. And let's try E before we go into our brain break. We're gonna kind of speed through our brain break. Sorry, my words broke. My brain break. We're gonna speed through our brain break. Let's have a look. I put a little breather for us here at the end. It's an easy one. All I do is I have my x and I'm applying law 3 over there. So that is going to be x to the power of 5 times 7. Can somebody tell me what is 5 times 7? I'm so sorry, Mohammed. 35. Thank you, guys. I love it that we are participating. 35. And that's that. So don't be afraid. Don't be afraid if you don't get the complicated ones as yet. As long as you're okay with ones like these, the complicated ones will come as you do more questions and as you become comfortable with that, like anything in maths. Cool. On to our brain break. For those of us who weren't here last week, because I see there's quite a few more than last week, what we are doing is we play One Must Go. So we have 4 options over here. And if you had to get rid of one has to go. Which one are you getting rid of? Captain America. Spider-Man! I did not expect that. I really didn't expect anybody to say Spider-Man. Thor. That's what I expected it to be, Captain America or Thor. Yeah, I think I'm also gonna do Thor. I don't know. I only like Captain America because I think he's like, you know, I think he's like the most handsome man on the planet. But I mean, that's kind of irrelevant. But yeah, Captain America, I couldn't get rid of him. I could never. So, so immediately, I don't know why Thor, but like, ish, I don't know. Yeah, he's just kind of irrelevant to me. Also, there was that one movie where he got fat, so like, I was just like, no, bro, what did you do? Why did you let yourself go like that? You know? So yeah, Thor is gonna have to be it for me. I mean, Spider-Man. Yeah, like I grew up with Spider-Man. Spider-Man was like, he did get fit again. That's true. But I don't know. He's just never been like a main character for me. Spider-Man has always been like the main character. Before I was really into Marvel, I was into Spider-Man. So yeah, that's that. Why Spider-Man? Yeah, I also want to know why Spider-Man. Okay, guys, moving on to our next one. Thor just has a hammer. So true. But he's also a god, you know? So that's that. Cricket, athletics, cricket. Okay, so we're getting rid of one. Soccer, rugby, athletics, cricket. What are we picking? I'm seeing a lot of crickets. Guys, I don't know if it's an Indian thing, but like, I think as an Indian, you grow up watching cricket, you know? I don't know if it's an Indian thing, but I just know like myself, all my family, all of my friends who are Indian, like we just all watch cricket. I don't watch it anymore, but I grew up watching it, so it's kind of hard for me to say let cricket go. You even use the cricket emoji. That's so disrespectful. Yeah, I would. Yeah, I saw someone said soccer. I saw someone said soccer, and I would have to agree immediately. You said soccer. I'm also gonna say soccer. I don't watch soccer. I have no interest in soccer. Like, don't ask me anything. Don't ask me if I watch the game. Don't ask me about the score. Don't ask me about this transfer. Like, no, I'm sorry. Cricket is a sport that I do not understand. Yeah. Cricket is the worst sport. Yeah. I suppose when you don't, like, when it's something that's like unfamiliar to you. Like, I saw a post the other day about like these people playing volleyball, and I was like, who watches volleyball? But it's just because I've never watched it, you know, I don't know the rules. So when you don't really watch something, it's kind of default to say it can go. Okay, next one. Okay, guys, this is for the rest of your life. You're giving up this thing, okay? You're either giving up your best friend, you're giving up having children, you're giving up having a spouse, or you're giving up having a beloved pet. And for now, I'm going to agree with you on a pet. I'm actually surprised. There's a lot of people I know who don't want to get married. I expected to see some spouses and children. I expected to see the spouse and children. A spouse, for anybody who doesn't know, is a husband or a wife, just a partner. So you're giving up a husband or a wife. You're giving up getting married. Children. There we go. I expected people to say children and spouses. Yeah, but I would also have to do a pet. I'm not really a animal person. That doesn't mean I'm abusing animals, guys. It just means I'm like scared of animals. I'm scared of birds. So yeah, I'd have to do a pet spouse. Yeah. Okay, and last one, guys. We have the invention of the wheel, the invention of the telephone, the invention of the internet, or the invention of electricity. Personally, this one I didn't know how to answer. Well, how about you gonna walk everywhere? Yeah, I see people saying wheel. Yeah, you guys are truly the next generation of technology. We can walk. Internet. Yeah, I would have to say maybe the telephone because I just wouldn't have a cell phone, which I'm okay with. Like I would have the internet, like that's fine. I can deal without having like a cell phone. Um, internet. I see some people saying internet. Yeah, I don't know. I couldn't go without the internet because obviously like we're doing lessons online, guys. How would we do MathsLive lessons without the internet, We have horses. I mean, that's true. That's true. We do have horses. But like, imagine now you want to go to like Durban or something. Well, I don't know where anyone is, but I'm in Joburg. If I want to go to Durban, am I riding a horse all the way to Durban? Like, you know, there's two refuelways. Oh, I did not notice. Oh, there's two refuelways. That's cool. Okay, that was our brain break, guys. It was a 5-minute brain break, but it felt good. My brain feels less tired. I hope everybody else feels the same. Without internet, phones would be useless. That's right? So who's giving up a phone? Because what are you gonna do with your phone without internet? That's why I said the internet, we can keep internet, but I don't need a phone. I can use like my phone on like a laptop or computer or even the TV. It was quick, and I do apologize, but on to the hardest stuff. No more TikTok. On to the hardest stuff, which is not really the hardest stuff because we kind of already did the first one. Okay. So we know what the first one means. Like I said, when we have two powers inside my brackets, what do? I apply my law to both of them. And so you look at what we did. We said a to the power of 1 times m and b to the power of 1 times m. And so that gave us a to the power of m times b to the power of m. So that one should make sense to you guys a little bit by now. Then we also have the one where we have a fraction or where we have division inside our brackets. If we raise a fraction to a power, how does that work? What we do is the same thing that we do with distribution with multiplication. I apply law 1 to my numerator, and I don't know why I keep saying law 1. I apply law 3, you guys. I apply law 3 to my numerator, and I apply law 3 to my denominator. And so what would that have looked like? I would have said a to the power of 1 times n over a over b to the power of 1 times n. Why 1 times n? Because a has that invisible exponent of 1, and so does b. And that's how we get a to the power of n over b to the power of n. Okay. So let's try this one now that we have an understanding of what we are going to do. So what I'm doing is, and guys, we can still keep our brackets if we want to. That's okay. I'm going to say 2 to the power of 1 times 2 times x to the power of 2 times 2 times y to the power of 1 times 2. Where I'm at right now in this sum, can you guys give me some thumbs ups? Do we all know that how I've applied law 3 to each one of my coefficients and my exponents inside my brackets? Tando, you've said you understand. Great. Anybody else? Is anybody else with Tando, or are we all lost? Anybody? Lufuno, thank you. Shady has got it. Refill it. Ma'am, so the 2 and the x are not together. No, they're not together. And if you go back up to where I was explaining it, I think it was right at the top with our revision. What we had said is that we said that our base and our coefficient are 2 different things. We treat them separately. And that's why I stressed on that, because that becomes super important when we're dealing with law 3. So let's go back down. Boom, boom, boom. There we go. Let's see. X is Twitter. Yes, ma'am, because every number has an invisible exponent of 1, 100%. Okay, I don't see any more questions, and I see thumbs ups. Thank you so much, guys. And then let me do this. And so now what do we have? I have, and again, I can keep my brackets if it's going to make things less confusing. I'm going to say 2 squared times x to the power of 4 times y squared. And then because I'm dealing with numbers over here, I know 2 squared is going to be 4 times x to the power of 4 times y squared. And that is going to give me 4x to the power of 4 y squared. But why is it called x? Oh, X, you guys are talking about Twitter. Guys, it was just renamed after Elon Musk bought it, but that's irrelevant. So let's not discuss that right now in our chat. Okay, so this is how we apply this law in a more complicated way. So I hope this makes sense. And before we leave, I want to do one where we do division. So if anybody has questions on this, please type it in the chat for me. Raise your hand. Let's talk about it. But I'm going to move on to the division one for now. I want to do a hard division one. Okay, so let's start with this. Immediately, what I can see is, okay, I want to apply law 1 to my numerator, and I want to apply law 1 to my denominator. I hope that made sense to everybody. And what is that going to leave me with? It's going to leave me with a squared over b squared. I hope that we're all happy with that. And just before we go, let's do this one. Why a hard one? Because we have to get used to the hard ones. The reason why we don't do well in the exams is because we leave the hard ones for the exams. No, let's not let the exams be the first time we see the hard ones. So here we said, aren't we supposed to subtract the exponents? Do we have the same bases, Bree? Remember, law 2 only applies when I have the same bases. So I'm not subtracting exponents over here. Why? I don't have the same bases. It is division and you're 100% correct. But remember, we always need the same bases for me to subtract my exponents. Okay, a little bit more of a difficult one. Let us look at this. What I'm going to do is I am going to apply my law 3 to my numerator first. And so let's apply it like this. I'm going to say 1 times 9, and then I'm going to say x squared times 9. So I did what I normally would have done if there was no denominator. I took my 9, my exponent, and I've applied it to everything in my numerator. And now let's do it to my denominator. My denominator is going to be y. My exponent is 5, and I want to bring in that power on the outside, which is 9. And so I hope that this makes sense to everyone. And let us just finish it off before we go. That is going to leave me with 2 to the power of 9 on the top and x to the power of 18. And as a closing off, can you guys tell me what is 5 times 9? 45. Thank you, guys. And that is that for our lesson. Also, what you should know is this 2 to the power of 9, you can put it into your calculator and get an answer there. So before we go, somebody, if you have a calculator in front of you, tell us what is 2 to the power of 9. I have my calculator. Oh, Pando beat me to it. 512. Great stuff. So our final answer would be 512 x to the power of 18 over y to the power of 45. And on that note, I hope that made sense to everybody. If